Greetings from the Subetha. This is Alan with another short color basic video, this time continuing a discussion about quick and easy ways to get bit patterns in a basic variable, specifically when you're trying to set a bit at a memory location. Maybe you're messing with the video display chip or something else, trying to talk to the hardware directly. Maybe there's other uses for that. And I talked about using 2 to the power of whatever the bit is, to get the value. And I also pointed out that it was really slow, convenient, but very slow. So here's another trick I used to do. If I was going to do a lot of bits, I could do something like this. Timer equals 0, 10, for I equals 1 to 100. And let's say I want to set bit 5, 30, z equals 2 to the power of 5. That's bit 5. Next, print timer. So this is our benchmark. We're going to set z to be the pattern for bit 5. And every time it does it, it's going to be substantially slower than hard coding a number. So I got 364. So I could do something like this. I would do a little trick where I might make a bit pattern, and I'll make it 7, so it has room for 0 through 7. And then for I equals 0 to 7, bit sub I equals 2 to the power of bit. Next. And you'll notice I'm using an array called BT and a variable called BT, which is wrong because it's actually called I. So let's fix that. There we go. Now if I ran that, if I just ran that and did an end, it did the calculation. See how long it took just to do 8? But if I print BT sub 0, I get 1, BT sub 2, and so on up to BT sub 7. There you go. So now I have an array that's got those numbers already in it for me. Now, if I was going to set bit 5, you could say z equals bit 5. So instead of it taking 361 or whatever it did, if you did that there, whoops, I should really get rid of line, what is it, line 1? Okay, what are we doing here? There we go. If I do this, instead of being 361, it zoomed down to 29, because now it's just looking up a pre-calculated value. So that's me pre-calculating data, which also means if I was going to do this same thing and make a routine that prints bits, for instance, let's do this. Delete 10 down. I'm going to have a value. I'm going to say, what is the bit pattern for a 5-5? Or let's 1, 2, 3, whatever that is. And I'm going to say, I have to do it backwards because the bits are numbered 7 to 0, so I'm going to say for I equals 7 to 0, step minus 1. Oops, let's do it again. For I equals 7 to 0, step minus 1. 40, if v and let's do it the slow way, 2 to the power of I, then print a 1, semicolon, else print 0. Semicolon, 50, next. Now if I run this, look at line 20, the value is 123, this will print the bit pattern. So I could actually do this, input V, and for line 60, go back to 20. So if I run this the slow way, I can say, what does 255 look like? And I probably need to go ahead and put a print statement here. Let's do that. Okay, what does a 255 look like? All bits are set. What does a 16 look like? You'll see it's, where is it? 1, 2, 4, 8, 16, and so on. What does 200 look like? There, but you see how it paints those numbers? Because it's doing the calculation each time. So if I wanted to do something like 20 for v equals 0 to 255, and 60 next. Now I'm going to print all the bit patterns. Look how slow that is. So that's doing the calculation for every single bit. But in line 40, instead of actually doing the calculation, if I just change this to say use my bit array that I've pre-calculated, significantly faster. So I use this when I want to print out what the bits are on the screen. I just pre-calculate using 2 to the power of bit, put it in an array, and do something like this. So there you go. That's a very fast way to print something on the screen. And if you made this a subroutine, you could probably speed it up a little bit faster, put it all on one line, take out the spaces. I don't know if there's many more things you could do to it, but there you go, a much faster bit printing routine simply by pre-calculating and using an array instead of using my 2 to the power of whatever. This also means in my last video where I talked about poking a value, like if I wanted to actually turn on lowercase again, which let's see what bit that was. Lowercase was, let's do alternate color. That's the alternate color is bit 3. So instead of doing poke and HFF22 comma peak of and HFF22 or, and I wanted to set bit 3, 2 to the power of 3, 6, go to 6. There you go. Instead of doing that, to speed that up, I could have said or bit 3, like that, BT sub 3. And that would do the same thing. And that would be much, much faster if I was trying to switch the screen on and off really quickly to change the colors or flash. In fact, we'll have to do some more bit math in another video. I had to do and or and all kinds of things trying to figure out how to do this for a test program. So until next time, don't panic.